A very good evening to one and all present here, guys. I welcome you all to the session. I believe every one of you is doing great and everything's been fine. So yeah, we have been meeting after a week, right? Okay, that's great. So guys, before we proceed further, where were we in the last session? Can someone please remind me of maybe like what exactly we did in the previous session, guys? Okay, let me just check it in our Google Drive. We'll get to know. Yeah, we were obviously working with linear regression, but what exactly we did? Okay, did I create a folder for you guys first of all? Like, where's your July ML1? Okay, so I can see here we have actually created one LSM file. Okay. So we have done reshape and the predict method. Okay, okay, great. So we have done until here, right? Okay, so in the previous session, this is what you have seen. So let me just upload the data again, guys, because now if you want to work again, then I have to run these files again, right? And if I have to run this file, I have to load the data again. But as of now, you can see there is no LSM1 with me here, right? So what I can do is I have to basically add this LSM1 over here again, and then we have to click on OK, and LSM1 is added here in this. You can see LSM1 is added. Now I can basically run all, and everything's gonna run fine, right? So this is what we have done. For input is equal to x is equal to 2.5. The output what we have received is 3.7, and this is nothing but this is according to our LSM method, which we have done it manually as well in the previous session. For x is equal to 2.5, we saw that y was equal to 3.7. Okay, so this is what we have done. But as of now, you guys want to visualize the data, right? We have not visualized the data. So if you basically want to visualize the data, let us just proceed further with that. So to do that, first of all, what do we need? We need matplotlib, right? So matplotlib.pyplot as PLT. We need this library, pyplot library, basically. Okay, and then to visualize the data, we have to go with plt.scatter, and then we have to give x and y. So these are our input and output. And after x and y, we have to also give the color. I mean, if you want, you can just give a color different. Otherwise, you can just proceed further with the default options. And then marker is equal to, let's say, I'm gonna go with D. And then I need plt.show. Okay, so let's see the data. Let's visualize the data and how exactly it looks like. Okay. PLR is not defined. Okay, PLT, sorry. Okay, fine. So this is how the data set basically looks like, whatever the data we have, right? So this is what the data basically looks like, right? So now what exactly we need to do is we basically have to, yeah, visualize. I mean, we have to basically find the best fit line for this data, right, guys? If we are not wrong, I mean, I'm not wrong, we have to find the best fit line of this data. Okay, so how do you basically find a best fit line, guys? How do you find a best fit line here? I mean, you know how to find a best fit line, but how to visualize it basically? So let me explain you some part over here. I believe you guys would understand this. Okay, so what we are trying to do here is, guys, we need the best fit line, right? So to find this best fit line, the first option what we need to do is we need to find all the inputs, the output. That is whatever the input we have, right? For 1, 2, 3, 4, 5. These are the original output, right? But we need to find the predicted output for all these inputs, like x is equal to 1. Okay, I might have to change the color here. Yeah, so for x is equal to 1, 2, 3, 4, 5. So these are the original inputs, whatever you are seeing right now. So for the value of 1, the value is 1. For 2 is equal to, the value is 4. 3 is equal to, the value is 5. Then again 4 and again 5. So these are x, this is y, and this is original y, right? Now, if you want to basically draw a best fit line, you need another y that is called as pred y. But what is that pred y? Pred y is nothing but we would take the same input here and we will try to calculate the value of the y pred by using our model. What was our model? Lin model, right? Okay, sorry, the value of 1 is actually 2. Chalo, okay. This is 2. Okay, chalo, fine. So the value is 2 here. Okay, those are the pred y value, right? So this is basically now what we have to do is we have to use this method, lin.predict for x is equal to 1. Similarly, we have to do lin.predict for x is equal to 2, 3, 4, 5. This is what we need to do. So if we calculate this 1, 2, 3, 4, 5, we are basically going to get this pred y, whatever we are expecting. Is this clear until here? Is this clear until here, guys? Please let me know. Is this point clear until here, everyone? Okay. So now, guys, if we want to run the lin.pred on all these 5 values, there's a shortcut to do is instead of writing this 5 times, what can we write, guys? Instead of writing this for the 5 times, like for separately for 1, 2, 3, 4, 5, what else can we do? We can just complete it within one shot. Yes, no, exactly. We can directly give our x variable. Whatever the x variable we have, we can go our x variable here, lin.predict. Okay, and then we are basically going to get some pred values. Whatever the pred value you have here, you are basically going to get some pred values. Let's say 2, then for 3, then 4, and then 5. Then this pred values will be in a linear line, obviously, right? So yeah, let us just find this pred values first of all. Okay, let us just find this pred values. Okay, so let me just do that for you. So instead of x comma y, what I'll do is I'll basically create a new code. Okay, forget about these drawings as of now. Let us just do lin.predict of x. Let us just do lin.predict of the complete x, whatever you have. And these are the values what you are going to get for your lin.predict x. And now let us store this value as pred y. Let us store this pred y as lin.predict x. Okay, lin.predict of x, let us store the value as pred y. Let us do that. Okay, I'll call it as pred y. Why? Because it is a predicted output, right? The original output is this, and this pred y is basically your predicted output. Right, so these are the original output, and this one is basically the predicted output. Now, if I have to visualize this predicted output, then what I need to do? I basically have to write the same equation here. Okay, let me write the same equation, and instead of y, what am I going to write, guys? Instead of y, what do I write here? The x value has to be the same. There is no doubt within that. But instead of y, yes, exactly, I have to go with pred y. So if you go this is what you are going to get. So this is what I was talking about, right? Yeah, I mean, a little bit here and there, but almost my like assumption was same, right? So this is your line. But the thing is, as of now, you are basically getting a single, I mean, the data points, the different data points, right? You're not getting a line here. So if you need a line, what can we do? We can just go with, instead of plt.scatter, we can go with plt.plot. Yeah, we can go with plt.plot, and there you go, guys. This is what your best fit line would look like. Okay, and if you don't need this marker, you can just go with marker. Okay, I mean, you can just ignore the marker, and you're going to get this best fit line. Okay, now if you want this best fit line along with your input data, then what we can do is we can do both ways. We can go with plt.plot, and then we can also go with this line. Here it has to be y, input has to be y, and color, let's say I'll give it as a black color. Okay, and the marker as D. There you go, guys. Okay, let me now clear this up. Now you know how exactly the pred y is working, so we don't need this drawing anymore. So let me just clear these drawings, and there you go, guys. Okay, so these are our data points, whatever you have, and this is the best fit line for our data points, whatever the data points we are looking for. Okay, and guys, if you're confused, like where do you find this line? Sorry, where do you find this file? Whatever I'm working with, then let me remind it to you guys. This is under the ML folder. If you go inside the Versio July ML1 folder, if you get inside the ML folder, open this file, and you would get the exact same things whatever I have done right now. Okay, it's exactly the same file. Okay, someone told me that they have missed the data file. I'm going to give you the link again. It's okay. You can go through it later. Okay, so yeah, this is what you have, right, guys? So yeah, this is how the notebook file looks like. And yes, so yeah, you might need the data file. So okay, get link. So all the data is present inside the data folder. Okay, guys. So let me just share this file once more with you guys. There you go, guys. This is the folder. So you have data files here. You have the machine learning files, and moreover, you also have the Python files which we have completed in the previous session. Okay. So yeah, this is what we have done, and this is how our machine learning file, the first equation looks like. Now, guys, if you want to figure out the coefficients, right, we are basically talking about y is equal to b naught plus b1x. Correct, guys? We are talking about b naught plus b1x. So if you want to figure out about that, y is equal to b naught plus b1x. So first of all, let us say I need to figure out what is b1. That's the slope, right? So if I want to figure this thing out, then how can I find it? What I need to do is I just have to go with lin dot coefficient. I just have to find out lin dot coefficient, and that is basically 0.6. Correct, 0.6. This is the same thing what we received in the previous session also, right, guys? The value of slope was equal to 0.6. If you remember, yeah, b1 we have calculated as 0.6, b naught as 2.2. Let's check b naught now. To check b naught, we have to write lin dot intercept. That is 2.2. Correct. Now, you guys might have this doubt saying, sir said the point would start from 2.2, but here the point is starting from 2.6 something, right? The thing is, guys, you need to understand that here the graph what you're seeing is starting from 1, not 0. If it would have started from 0, you would have this line started from 2.2 as well. Okay. So if you want to change this parameters, there is a parameter called as rc.param. So if you go and if you want to reconsider your graph options, your origin points, you can actually reconfigure the origin points over there. Okay. You can always do that basically. Okay. So that is lin intercept and lin dot coefficient. Okay, guys, so this is what the equation says. So whichever the point you need to figure out, you can basically find that equation by using this linear regression. Okay, so this is the basic concept of your linear regression. If you have any doubts until now, please let me know right away, because now we are going for a next real world example. This was just a curated example, right, guys? I have done it on my own and I've given you the data. So this is just to understand how linear regression works. But the practical linear regression, we are going to apply it right now. So if you have any concerns until now, please let me know. Okay, until then, let me add the next data file what we are going to work with. So that next data file is nothing but which data shall we work with? Okay, salary data. Chalo. So we basically have salary data here. So if you look into the salary data, guys, you have the total number of years of experience and then salary. Okay. So you guys, okay, you can see there are 32 inputs here. No, 30 inputs actually. Yeah, 30 values actually, because the first one is over here. So yeah, years and experience, that's the column name. Anyway, this is the years of experience, this is the salary. So what kind of example is this? Is this a regression problem or a classification problem? We basically have to predict an individual salary by giving the total number of years of experience, right? So that is basically the total number of years of experience what we have. You just give the years of experience, and at the same time, the output will be your predicted salary. That is what salary you should have according to the industry standards. But here again, this is also a basic example, guys. This is not the high-end example, because here you just have a single feature. But in a real world scenario, I told you, right, we basically have hundreds and thousands of features, but we're not going to work with that as of now. When the time comes, I'll explain you how to deal with those. Okay, but as of now, you can see this is only one input, one output. Okay, so there you go. So this is basically the total number of years of experience you have, and then you also have the total number of, what is the salary of this previous people. Okay, so now we have to define an algorithm here where people would come and they would enter their years of experience, and then they would say that this is the salary what they need to make according to the standards. Okay, so this is what we basically have with us right now. So this is basically a regression problem, right? Because here, whatever we are expecting is of a continuous value. So this is going to be a regression problem. And obviously we are going to use a linear regression here. Now you guys tell me what is going to be our features and what is going to be our label in this data set, whatever we have. Okay, let us just load the data set first of all, and then I'm going to ask you guys. Okay, so let us create a new notebook. Yes, Cybernet, correct. Okay, Harshanknam, correct. Okay, dataset is not there in the link. Why dataset is not there in the link? It should be there, guys. Come on. Did you refresh the dataset, Koganti, Harshanknam? Just refresh your folder and you should get it actually. Yes, Nayan, correct. I'll show that one. Guys, are you able to see the dataset? Please let me know, because I'm getting some response here saying the dataset is not available or not visible. So are you getting the dataset? Please let me know. Salary data. Okay, got it, right? Everyone. Okay, apart from Koganti, everyone is able to see the dataset. I don't know what's the issue. Let me try giving the dataset in the chat section. Let me just check, because it's updated and it doesn't allow me to share the dataset, guys. Okay. Let me just check once. The Zoom have updated themselves. So Anyway, let me just give it to you. Yes, it's possible. Okay, anyway, now it is visible. Anyway, I have given you the data set in the chat box as well. So if you get the data set, yeah, you can work with that. Okay. Anyway, let's load the data set first of all. So the data set would be kya data? What are we working with? We are working with LSM. I mean, we can also type it as SLR or salary predict. Okay. Yeah, I'm going to type like this. SLR, that is, SLR stands for simple linear regression. Why does it say simple linear regression? Because we just have a single feature. That's it. We just have a single feature. That is the total number of years of experience. That is the only feature we have available with us. That is why it says it is called a simple linear regression. Yeah, when you have of more than one feature, we actually call it as multiple linear regression. Anyway, let us load the data set here. Salary data, right? Okay. So first of all, load pandas. Input pandas as pd, and then df is equal to pd.read underscore csv. And let's copy the path from here. And then if you do a df, this is what your data frame looks like. At the same time, let me locate the file in your location as well. Okay, so there it is. So let me just move it to our folder. So where is that folder? Versio July ML1. Okay, there you go. So guys, if you look into the ML folder, I have added one more file, that is SLR salary, which I'm working right now. So, okay. So what is the first thing we need to do here, guys? In this data set, what is the first thing we need to do? Yeah, for that, let me just show the machine learning steps again. So what are the machine learning steps it says? So the first thing is we have to take the data. So in our case, yeah, we have basically imported our data. We have loaded our data set. So first step is done. Now, do we have to filter the data? Do we have to clean the data, guys? No, we don't have to, because it looks good. It looks exactly the same way and it's filled. So we don't have to even filter the data. The data looks good, right? So second step is not required in this equation here. Okay, now let's just talk about input and output. Here you can see we have got input and output, right? So yeah, divided into input and output. So what is input and output? We have already done this. So what is the input? What is the output? The features are the input. Output is the label, right? So years of experience is the features, salary is the label. That is, X is basically years of experience, Y is basically the salary. So let us just proceed further and divide our X and Y. So X is equal to df.ilog. Okay, X is equal to df.ilog. So what are the rows I need? I need rows from 0 to how much? 30. These are all the rows I need, 0 to 30. And what is the label I need? I mean, sorry, the column. Which column do I need? I need only the first column, that is 0 dot values. So this is what I need. So if I type X, it should say all the number of years of experience, right? Now, the thing is, guys, instead of giving 0 to 30, I can also go with 0 to nothing. Okay, I can also go with 0 to nothing, and my X would remain exactly the same. One more thing, there is no mandatory of writing even the 0 here, because it will assume that it is 0, and if you don't have anything at the last, it will assume that it has to go until last. So you can see, guys, you can also write 0 to 30 if it is confusing you, or you can also go with this option where it is not like, you know, I mean, it looks neat, more neat, right? Less number of writings and the code looks good. One more thing we are missing here. What is that thing, guys? We are missing one more thing over here in this equation, or in this process. We are missing one more thing. What is that? Yes, exactly. We missed out. Yeah, we missed out the reshape of this. That is, we have to convert it into 2D. You have seen, right, in the previous session, lin.fit, our algorithm lin.fit actually requires, yeah, let me just show you, lin.fit, right? So this algorithm expects the input, that is X, into 2 dimension. Why? Because see, as of now, we are working with basic data set, so that's why we have a single feature. But in reality, your lin.fit, okay, if you're working with linear regression, there are a high chance that your X, whatever the value of X you have, it will be in 2D. So that is why it expects your data to be in 2D, because if you're taking 2 features, then obviously these 2 features will be in 2 dimensions, right? If you have more than one feature, obviously the data will be in 2 dimensions. If you take 3 features, 5 features, 10 features, 100 features, the data will be in 2 dimensions, that is columns and rows. But here you just have 1 dimension, right? So that is the reason it expects the data to come inside in 2D. So that is the reason why we are trying to convert a data into 2D here. Okay, in reality, it is not required, but because of this lin function, it just accepts the data in 2 dimensions. That is the reason why we have to reshape this. Okay, now during the reshape, what did we do in the previous session? In the previous session, I believe I did something like this, like 5,1. And okay, before that, let us check the shape first. Okay, let us check the shape of X. What is the shape of X? That is 30, nothing, right? The shape is 30, nothing. So what we can do is we can go with reshape 30, 1. And now if you basically type X dot shape here, it says 30, 1. If you do a reshape, you can see the data is in 2 dimension. If you take the dimension of X, it would say 2 dimension now. 2D. Earlier, if you would have checked, it would have said 1D. But now it is of 2 dimension, and the value doesn't change, guys. The value of X doesn't change. If you see, the value remains exactly the same, but it's changed into 2D. See, 10.5, 10.3, 9.6. The value is exactly the same, but this was in 1D. Now this one is in 2D, right? So that is the difference, guys. Okay. Now, guys, one more thing what you need to understand is instead of giving 30, 1, we also have the option to reshape it by giving the negative indexing. This is forward indexing, right? 30 is basically the forward index, but instead of 30, you can also go with negative index. You can go with negative indexing. So if you give -1, you are basically going to have the same thing. If you try X dot shape here, your shape is exactly the same. There is no change. It is exactly 30, 1, right? There is no change. Yes. Okay. So understood, guys. This is how your X look like. Nayan, just now I explained you. Instead of 30, 1, I have given -1, 1. Okay. Instead of writing 30, 1, see, if you write 30, 1, it's also the same thing. If you write -1, 1, it's the same thing. Why? Because here I'm giving the forward. Here I'm giving the forward, indexing. Here I'm giving the reverse indexing. So forward indexing is 30. This is -1. So it's basically the same thing, right? So if you want to call out your index or call out your value, either you can call it by forward indexing. That is 0 is this one. And if you can also want, you can also go with reverse indexing. So that is why I've given -1, 1. Okay. So don't get confused with this. Okay. So similarly, we need the same thing for Y, but in Y, what do we have? Yeah, df.ilog. And then instead of 0, what column do we have to work with? We have to work with 1. Instead of 0, we have to work with 1. Dot values dot, see, it is not compulsory to reshape Y, because Y every time has to be of a single column. You cannot have multiple columns for Y. So that is why it's not important to go with reshape for Y. Y can be in 1D. It's not a problem. Okay. If you're checking the Y dot shape, okay, or ndim, you can see that Y is basically in a single dimension. Okay. Or Y dot shape. Yeah, again, it's in single dimension. We don't need Y in 2 dimensions. So that's why X and Y. So this is your X and this is your Y. So we have divided the data into input and output. Is it understood now, guys? Have you guys understood until here? If you have any doubts, any concerns, please let me know. I expect you guys that you have understood everything until here. If I'm going to give you a minute, if you have any doubts, you can ask me, and then we shall proceed further with the next step. Okay. Okay, so let us proceed further. Okay, so let us proceed further with the next step. Excuse me. Excuse me, guys. Yeah. So what is the next step, guys? The next step is to divide our data into input and output. That is the next step. We have to divide our data into input and input and output we have done. The next step is to convert our data into train and test variables. Okay. So the next thing what we need to do is we have to basically convert our data into train and test variables. Okay. So how do you do that? How do you convert your data into train and test variables? What is train and test? So this is actually a very important concept, which I want you guys to understand it in a really great manner. You shouldn't have any doubt once I have explained you this. Okay, so I want every one of you, like all the 90 participants here, need to understand this, because this is the most important concept in your machine learning algorithms. Okay, so please understand this part. Let's say, let me just give you an example of a student. Okay, let's say this is a maths class going on, and students basically have 10 questions overall. Let's say there's a maths class going on, and the teacher basically have only 10 students to teach the students. Okay, so now what the teacher do is, he or she basically, they basically teach the students all these 10 questions. So total of 10 questions they had. Out of these 10 total questions, so what the teacher did was, they basically taught all the 10 questions in the class. Okay, so the student, I mean the teacher basically teach or taught, actually the past tense is taught, but I have written the present tense here, but the student basically have been taught all these 10 questions, okay, in the class, maths question. Now what happens is, there comes the examination. There comes the examination, and in this examination, okay, in the examination, the teacher basically asks the same 10 questions. The same 10 questions, whatever have been taught in the examination, the teacher basically takes the test on the same exact 10 questions. Whatever they have been taught here, the same 10 questions they have been taught here. So there's a student called ABC who basically scores 100% out of this. My question over here is, would you call this student ABC a genius at mathematics? Or would you say that this ABC have understood the concept of maths in a very great manner? Would you say that? Please tell me. Yeah. So guys, in this scenario, we can say that ABC might be good at maths or might not be good at maths. Why? See, this student might be clever or this student might be intelligent. What do you mean by clever? Thing is, this student might have understood this only 10 questions. Like, okay, how these 10 questions actually work in real. So he or she might have, like, understood these 10 questions, and the luck was good. They have actually got the same 10 questions in the examination, and they received the accuracy of 100%. So we can say that 100% this student is 100% clever. But if we ask that whether are they intelligent at maths, whether have they understood the complete concept of maths, no, we cannot answer that. Why? Because they already knew what is the answer going to be for these questions. So it was comparatively easier for them. This is what happens even in our schools, right? Even in our schools, this is what we do. The same exam, I mean, the questions, whatever have been taught in the in the classes, the same have been asked us in the examination. And then we score 90, 95%, and then we get happy that, yes, we have done something good. But in reality, yes, and one more thing, guys, it's not that this ABC is 100% they have not understood maths. I never said that. I said it might be, it might not be. But this is not the correct way to evaluate students' intelligence. Do you agree with me or not? This is not the correct way to identify whether the student knows this mathematics concepts or not. This is not the correct way. This is what my assumption is. Do you agree with me or not? Yes, you do. Right? Because you have common sense, you know that, yeah, this is not how a maths ability of a student would be interpreted, right? So instead of this, I have another way. Okay, I have a better way. That is, if I were the teacher, what I would have done is, because I know, like, what is the difference now? I mean, if it was earlier than machine learning, I would have done the same process. But now I know that this is not correct. What I would do is, let's say if I'm the teacher, okay, so I'm the teacher here, I know that there are 10 questions. So what I would do is, I'll basically divide these 10 questions into two different parts. One is for the classroom teaching, okay, and one is for the examination. And what I will do, I will, out of these 10 questions, I will take 8 questions for teaching, and these 2 questions, I won't show it to the students at all. I won't show them questions at all. Forget about the answers. I won't even show them the questions. These 2 questions, I'll reserve it for the examination purpose. Now what I do is, now I take the examination, and in this examination, I give the data with this. Sorry, my bad. Yeah, in this examination, see, we have trained our students with this 8 questions. Now our student knows how to work with maths problem. Let's say again, this student is XYZ. Okay, now instead of testing with this 8 same questions, I don't want to test with 8 questions, but I just want to test it with 2 questions. But these 2 questions are new questions. I am testing with only 2 questions now. Now, if you receive 100% accuracy here, then we can come to a conclusion that this person XYZ is really good at maths, because this person actually solved the question which was not taught to him or her earlier. They did it on their own. They solved this question on their own. So we can say that, yes, this is working 100% correctly. So now can we say that XYZ is good at mathematics? Yes. Now we are in a position to say that, yes, XYZ is good at mathematics. The same concept we use in our machine learning algorithms. Okay. So what we are going to do is, guys, okay, let's say we have got 100 inputs, okay, 100 data points. if we are giving all these 100 data points, and yeah, data points as in X and Y both. Okay, I meant to say input and output both. So if you are training your algorithm with all these 100 X and Y, and then if you are working on the predict, okay, for this predict again, for this predict, what you do, you give the same X, whatever the X value you have in here, you give the same value, then you get a Y value over here. This is what it happens, right? So what is this Y value? Yes, you are getting a pred Y, like whatever you have received, right? Pred Y. So is this pred Y more accurate, guys? Are you dependable on this pred Y? If we go with this method, this is the same thing what we did in the previous session, right? We had 5 values for input and output, 5 input, 5 output. We trained 5 input, 5 output. But while predicting time, we gave 5 input, the same 5 input, whatever we have trained, and we call it as pred Y. This is not actually how it's done. If you do this, your model would be called as a biased model, because you are asking the same questions to your model what you have thought. In the predict option, you are giving the same option. So that is your training data set, right? So what we do here is, instead of this 100 values, even we are going to do the same approach. We are taking the same approach. What we are doing is we divide the data into train and test. Then yeah, X and Y, guys. Okay, you need to understand that here you have X and Y. Here also you have X and Y. Let's say 80-20. 80 data over here, 80 X and Y over here, 20 X and Y over here. Now what we do is we basically build our model. We build our model by giving this data. Now if you want to predict the model, what we do, guys, we just take X over here. We don't take Y. We just take X over here, right? We give the X to our predict, and whatever the prediction it gives us, that will be called as pred Y. Do you believe me? Do you agree with me until here? Do you agree with me until here? Like whatever the X we give here, it will be called as pred Y. Okay. Now the name would get confused, right, guys? Here also we are giving XY. Here also XY. So what we'll do is we'll call the original data set as XY. Okay, and remaining I will call it as train X, train Y, and here I will call it as test X, test Y. So this is test X. Okay, this is my test X. This is train X, train Y, which I have modeled my model. And for testing, I have given the input as test X, and the output what we are getting is pred Y. Now, guys, what if I want to evaluate that whether this answer is correct or not? Then, with whom are we going to compare this pred Y with? Tell me. In the on the screens, you have this data set. You have the pred Y model with you, which are the predicted model of test X. With whom are you going to compare your pred Y so that you can understand the data is same? No, compare. I mean to say the solution, the answer. Yes, Shrishti, correct. No, Raunak, please understand this part. Here, I have told you that this exam, 2 questions they have given, and the question is correct. But who said that this question is correct? The master, right? The examiner, he or she already knew that what is the output here, what is the answer to this question. Then they evaluated this answer with the student's answer. So what is that answer available here? Yes, that answer is nothing but your test Y. Your input is test X, your output is test Y. So you compare your test Y with pred Y. So depending on this accuracy, we say, yeah, the data is basically something like this and something like that. Our data is 85% accurate, 90% accurate. That is done on the basis of this, because test Y is actually the original output from the same data set. But this test Y, your model doesn't know anything about this test Y. Okay. And then we would basically get the correct assumptions. Okay. Dhriti, okay, if you directly predict trend X, then what will happen is instead of test X, you will get the output of biased model, because your model already know that what is trend X, right? So your model will, I mean, the output, whatever you are getting, it will be a biased output, because it knows already what is train Y, because while training, you have given train X and train Y both. So your model would already know what is the output of train Y, and it will try to fix that output if you are giving a new input. But in this case, this is not the reason. The output is completely new, right? So that is your train and test variables. Have you understood it, guys? Or if you have any issues or concerns until here? Okay, Sai. See, what we do is, please listen here, guys. Those are still confused, please listen. We have 100 values of train, and I mean overall 100 values of input and output. We divide 80-20, like 80 inputs, 80 output here, and then 20 inputs, 20 output here. Now what we do is this train variable, where we have input output both, 80% of the data, we give it to our model. We train our model on the basis of train model. Okay. Now, if you want to predict, let's say we are building a salary. Okay, and in this salaries, guys, let's say you have different types of years and all, but you don't have the years of experience of 2.5. Now, whatever the model, your model is predicting, like let's say 2.5 years would give a salary of 50,000. So who will basically say that this assumption is correct? Who is going to tell you that whatever the assumption you have of 50,000, that is actually correct? How do you make sure that this output is correct? How do you do that? By finding the accuracy first, finding the error. And to find out this error, you basically need your test data. And now to understand your test data, we don't test our data with the same value. To figure out our test data, we don't test the data with the same training value. We don't do that. Why? Because our model will be biased. So what we do was, this 20 data, which your model have never seen, this 20 data, your model doesn't know what is the input and output of this data. We just give the input of this 20 data, and there comes the output. Now this output is compared with this output. And then if it is matches, we say, yes, the data is matching correctly. And now we basically deploy it into a real environment, and then people actually use it for the assumptions. Okay. Yeah, Nayan, I was talking about if directly if you're predicting the output, how would you understand that this data is valid or not? Like if it is giving 50K, how would you assume that this is correct? Because you have not tested your model. So to test your model, you basically give the data from your test. And then once it says the accuracy is 97, 98%, we can say, yeah, 50K means the data would be around 49 to 51K. We can assume that the salary would be around 49 to 51K, something like that. Okay. Okay, so if we get an accuracy less than let's say 70 or 60, there is no point of building the data. Right? So we need to make sure that we need to get an accuracy somewhere around 80%. And another thing is, it also depends on what model are you working on, like how serious is that model. So if you're working with something really serious, you need to have an accuracy of 97, 98%. But if it is not that serious, it's okay if you go 1 or 2 years, you can say 95, 96 is also better. But if you're working now, as you're in the training sessions, if you're working with your algorithm for the first time, then we can say 70, 80% is fine as of now. 80, 85, we can say. We can keep the goal of achieving 80, 85 for all of our outputs. Okay. So yeah, this is your train and test variables. Okay. So how do you train and test your variables, guys? I believe everyone have understood this point, right? Until here. Okay, great. So now to train and test your variable, there is another library which is actually required. Yeah, so there is actually a library which is required, which will actually do this. You don't have to do it manually, but there is already a library which actually do this. Okay, so this library, again, you're going to get it from sklearn. So I request you guys to visit sklearn and go for model selection. Inside sklearn, you have to go for model selection. And in here, you are basically going to get some train test split, the search for train test split, and you would understand it. Okay, so the one what we are going to do is from sklearn, yeah, dot model selection, yeah, model selection, import train test split. You have to import this class train test split, and now you have to call this train test split here directly. And in the train test split, what is the data we need, guys? X and Y, right? So X is the 100% data. We have to give 100% of the data here. That is X and Y. And the next thing after X and Y is the test size. So how much is the test size you want to give? Like, how do you want to divide the data? So I've given you an example of 80-20, right? So let's say you want to divide the data on the basis of 80-20. That is 20 is the testing size, and 80 is the training size. Okay, so in most of the cases, guys, if you consult or if you basically try to talk to your data scientists or machine learning engineers, they would say, like in most of the cases, to have a balance in between, we go with either 70-30 or 80-20 or anything in between 70-30 to 80-20. That is considered good. You can also go with 75-25. If you want to go with 75-25, what you can do, you can go with 0.25. That is the only change you need to do. Okay, so that is the thing. Now, guys, once I run this, then I might need different variables, right, guys? This X and Y. If I'm trying to split the X and Y, I might need different variables to store the data. Correct? So how many different variables do I need? In this case, how many different variables do I need, and what are those variables? Can you guys please let me know? What are those variables we need? Okay, what are those variables, Nayan? Can you please tell me? Yes, so we need basically 4 variables. First of all, 2 variables for train, 2 variables for test. Train X, train Y, test X, test Y. So these are the 4 variables what we actually need. Okay, train X, train Y, test X, test Y. Train X, train Y, test X, test Y. So this is what we need. So run it, and there you go, guys. So sorry, my bad, guys. Yeah, I've done something wrong here. What is that? This is not what we give. Why? You would see train X dot shape. No, you don't have to do anything in sklearn. I just told you that we will get a library from here. That's it. Yeah, you can see train X dot shape is 24,1. So we had 30 values. 80% of 30 is 24, right? So we have got 24 values. But in train Y, what do we have? We also need to have 24,1, right? So how can we do that? Train Y dot shape. If you want to check it out, we can go with train Y dot shape. And do you see any problem here? Is there an issue here, guys? Yes, this is an issue. See, whatever the number of train X we have, we need to have the same number of train Y as well. But we are getting 20% of the value. Why? Because this is not how you give it. you basically write train x first, and then the second variable is test x, and then comes train y. This is the standard procedure what you need to use. Did you understand, guys? This is the standard procedure what you need to use. Train x, test x, then train y, test y. Okay, because see, whatever the name of the variables you give, it really doesn't matter to your train test split library. It will just split the data in this form. It will basically divide the data in this form. First, it will take x and 80-20 here of x, and then it will do 80-20 here on y, 80 here, 20 here. This is how the train test split works. Even though if you give a different names here, the data will be divided in the same fashion. First, x will be divided into 80-20, then y will be divided into 80-20. So you remember this, guys, during your train test split, you have to follow the same order. You cannot change the order, guys. There is no way you can change the order. You have to go with the same order. Okay, so this is what you need to do, guys. Is that clear? Okay, so now let us run it again. Now we can see 24,1, 24,1. Okay, 24, nothing, because this is 2D, this is a single D, right? Okay, now let us just check what I have got in test X, the values, whatever I have received in test X. So these are the values what I have received in test X. Are you guys getting the same values? Just check. Are you guys getting the same values? Yes, you will definitely have the 6 values, but you might not have the same values. You might have different values. Correct? Yeah, because the split is done on a random basis. So we don't know what based on the basis it have split it, right? So if you guys want that, even mine and your values has to match. If you guys want we to have the same values, okay. So what we can do is we can basically go with another parameter here, which is called as random state. And the parameter name would be random state is equal to 0. So if you give random state is equal to 0, there is a specific random pattern which happens with random state is equal to 0. So all of us will have the same pattern. And if the data is also same, then we would end up getting the same testing data. I believe now every one of you will have the same data, that is test X. If you check your test X or any of the variables, you would have the same data as me. Yep. Now you are going to have the same data. That is the use of random state. Okay, it's not required if you are working on an individual project. Okay, we did this because we are doing it on a mass. Like everyone is working on the same data sets, right? So just to match your results, so that your results and my results are same, and my data and your data are same. That is the reason why I gave this random state. Otherwise, it's not required in real practice. Okay. Excuse me. And yeah, even in real practice, guys, if you think the data actually whichever have been chosen for training and testing, which is better, you can actually go with that much that amount of random state. Okay, so now train test is done. Okay, guys, I believe everyone have understood what is train and test, and you're never going to forget this. Okay, even though if you have understood it now, after this session has been uploaded, please watch this again and again just to make sure you don't forget this. Okay, so train test is done. Okay, now the fifth one is normalizing the data. We don't have to normalize the data here. Okay, I'll tell you when to normalize the data, but as of now, it's not required. Okay, so we can skip the fifth step. Let's run the sixth step, that is run a classifier or a regressor. So this is a regressor problem. So again, we have to go with from sklearn.linear model. We have to import our linear regression. Yeah, we have to get our linear regression and the same thing. Okay, we have to create a class of linear regression. Yeah, lin is equal to linear regression. So this is what we have. Now, what is the next thing, guys? Once we have created our regressor, what is the next thing? The next thing is we have to fit our model, that is train our model, right? So to train our model, what do we have? Lin.fit, and then you have to provide your training data. Okay, you have to provide your training data. So what is the training data we need to provide here? Yes, Yash, exactly. So guys, can you help me? What is the training data I have to give? Do I have to give XY? Yes, the training data should be XY, correct? Yes, guys, is it correct? Yes, exactly. This is not correct. Why? Because we have split the data here. If you are giving XY, what is the whole point of doing the split and all? So what we have to do is we have to go with train X and train Y. So train your data with train X and train Y. Yes. So basically, lin.fit X comma Y. Instead of X comma Y, what we have to go with? We have to go with train X and then train Y. Okay. So there you go. And yeah, one more thing, guys. Did you notice that we didn't reshape train X? We didn't reshape train X. We just created train X and we proceeded further. Why? Because it's already in 2D. Because we have reshaped it earlier itself. That is the reason. Okay. Anyway, let's not get confused with that. Anyway, this is lin.fit now, train X, train Y. What is the next thing what we need to do, guys? What is the next thing we need to do here? We basically have to predict the output. Yeah, I was talking about this now. So now let's say if I'm going lin.predict, and here, what is this? This is basically the number of years of experience. You basically have to give the number of years of experience, and then this will actually give us the salary, right? So for 2.5 years of experience, what is the salary a person should receive? Oh, I was actually correct here. Okay, that was just my assumption. But here, yeah, it says 50,000. So with a person with 2.5 years of experience, he or she is going to get 50,000 of the salary according to our model. But who says that this model is correct? Who gave the permission that this model is correct? This model is working exactly the same way. We did check it, right? We have to first validate our data. So how do we validate our data? We validate the data by taking our testing data set, right? So for that, what we need to do is, okay, Shrikant, just a minute. I'll go through it. First, let me do this thing. So what I do is I basically want to check my data. So to check my data, what I do to validate my data, I check the data. I'm going to check my data with this variable, that is x test, which I have already explained you already, right? X test or test x. Yeah, the name is test x, I believe. Test x. And this output will be called as, what is the output of test x will be called as? Tell me guys, what is the output of this test x will be called as? Yes, this will be called as spread y. So run this. And now if you run this up, what happens? This is what the prediction we are getting for our test x. Okay, so which was our x basically? Our x was nothing but test x. So this is the test x. These are the predicted values of this spread x. And what are the original values? The original value is your test y. So this is your original value, guys. This is your original value, test y, and these are your predicted values. So now you see the changes in here, like what are the total error happening in here? You can figure it out. Okay. So basically, it looks good, basically. So here it was 40,700 is 37,700. So 3,000 difference. Here it's exactly the same, 122, 122, only few hundreds of difference. Yeah, there you have a very huge difference. That is 8,000 of difference in between this third value. In the fourth value, it's almost again the same. Here also it's just 1,400, not a problem. Here also it's around 1,400. So basically the data is actually good. If you leave only one data out here, the data actually performed better. So now if I say that I want to predict a salary of a person with let's say 3.5 years of experience, then we can say that, yeah, this actually according to our model is 60,000, but you can say plus or minus 2 to 3,000 you can expect. Okay. Now accuracy, we cannot directly predict accuracy here because accuracy is meant for our classification models. For regression models, we have the error evaluation. So we have to evaluate the errors here, like what exactly the error we have and how to evaluate these errors. Okay, so in the meantime, guys, yeah, this is what we get. Now I'll show you how to calculate the error. But before that, I might need a small break, guys. Okay, I need 2 to 3 minutes of break. So in the meanwhile, guys, if you want to work with this, you can just go through it. And then if you have any sort of doubts, please ask me. And once I'm back with it, I'm going to explain you how to calculate the errors. Okay, and now if you want, you can also visualize the data. Try visualizing the data, try plotting the best fit line. Here you can get two best fit line, one best fit line for your training X and another best fit line for your testing data. So you can just work with it. And if you have any concerns, any doubts, you can just post your doubt here. I'll try to answer the doubts once I'm back with it. Okay, so here there was a screenshot. Shrikant actually gave me a screenshot, says some error. So let me just check that one and then I shall leave for the break. I mean, get a break. Okay, so what is the error you're getting? Fit missing one required positional argument y. Train x, train y. Okay, you have given train x, train y. Here, क्या नाम है? Shrikant, give the parenthesis in front of class here. You are creating an object out of the class, right? So give a parenthesis in here after linear regression. Write a parenthesis. Okay. Yes, correct. That's correct. Okay, chalo. Thank you guys. I'll be there within 2 to 3 minutes. Okay. Until then, if you have any doubts or concerns, you can ask me. Otherwise, you can practice that visualization of the best fit line. Okay. Try doing that. I'll be there within a few minutes. Oh, sorry, guys. My bad. I forgot to unmute. Yeah. So as I was talking about, guys, we need to work with error evaluation here. Okay. So if you're talking about error evaluation, then what are the ways to evaluate the error? So the first way, what we have is basically called as MAE, or it is also called as mean ups. Yeah, mean absolute error. Okay, so the first one. So what we have done is we are basically calculating the error here. But if you calculate the error, you can see some errors are negative in side, and there are some positive errors also. So to avoid this, what can we do? Because we are just worried about the magnitude. We are not worried about the direction here. So what we can do is we can basically use absolute of this error. So take the absolute of this error, and this is what it says. And finally, the final procedure, what you need to do is you basically have to take the mean of this error. Like whatever the error you are getting, just get the mean of this error. You run it, and this is what the error you get. So this is what the error you have. So are you guys getting the same error? Yes, are you guys getting the same error? Please let me know. It's different. How is it different, man? Have you done the same thing? Okay. So this was the manual method how you can actually calculate the error. So now you are getting an error of 2,400, right? So let's just consider the error of 2.5 thousand. Okay. So for the experience of 3.5 years, we are getting a salary somewhere around 60K, right? But we know that we actually have a different an error here. What is that error? That error is nothing but plus or minus 2.5K. So 60,000 is the value, but you can consider that the actual value might vary from 57.5 to 62.5K. This is what error evaluation actually helps you with. So now after error evaluations, you know that how much accurate your model is. So you can basically give the error evaluation, like your error along with the data. So now people can be relaxed and they would say, okay, so this is what the salary I need to have. Like this is not a compulsory thing. It can be 58, it can be 62, 61, whatever it is. If you have. Okay. So apart from that, if you want to calculate this error, okay, by directly by using a library, like you don't want to do this every time. If you want to do it from your library, then there is a library which actually helps you to do that. That is nothing but from sklearn. You just have to go for metrics, and then the metrics what we need to use is metrics dot mean absolute error. Yeah, there are various kinds of errors, guys, but as of now we are focusing on mean absolute error. So what is your mean absolute error? You can see the parameters. It's asking for y true and y pred. So what is your y true? That is test y, and then that is pred y. So give your test y and pred y, and then yeah, it's going to give you the same error. If you check this and this is going to be same error. Okay, understood, guys? Yes, please let me know. Have you understood about the error evaluation techniques? Please let me know. Okay, fine. So this was about your basic linear regression. Okay, guys. So now I'm going to give you some assignments. I mean, not now. Maybe tonight or tomorrow, I'll actually add some assignments for you, and you guys actually have to work with that assignment. Okay, so you basically have to make a linear regression. You have to find these errors and you have to optimize this error into much less value. So this is like 2,500, right? So we had a value from 20,000 to 1,40,000, 1,50,000 something. So we can say our model is almost 93, 95% accurate. So it's actually a good one. So someone actually told me about the score. Let us check the score here. Score is also again I think it's going to be the same thing. So train X, train Y, let us check. Okay, 94.11. Yep. And with test, what is our data with test X and then test Y? Oh wow. Okay, with test X and test Y we are getting an accuracy of 98.8, And but here the situation is reversed. Like we thought train data would be biased one and it would be more accurate, but here no, test data is working much more better than the training data. That's a great thing. Or maybe wait guys, wait. I think I have to give pred y here instead of test x. Just a minute, let's just check. What if I give pred y? Then what happens? No. Test y. Yeah, that is the correct thing, guys. So with test data set, yeah, our model is really accurate. You can see, guys. No, that 100%, that's a different thing. So don't worry about that one. Okay, so our model is somewhere around 99% accurate. It says so, and on training data set, it is 94% accurate. Okay. Anyway, so this is how it actually works like. Now we shall go for multiple linear regression. This was a simple linear regression, right? Now we basically have to go for multiple linear regression, and let's see how to work with multiple linear regression. Okay, so let us give you the data first of all here. Oh, sorry, not here, right? I have to give the data in the data folder. I think advertising.csv. Let us check once. Let me just check once. I think it is advertising.csv. Let's check. Yes, it is. So let's just load the data set. Create a new model and load the data set. Let me open a new notebook. We can go with MLR. Adds error. So MLR basically multiple linear regression. Okay. So first of all, pandas. After pandas, I have to load the data set, that is df is equal to pd.read underscore CSV, and the data is this. So if you go with df, this is how the data looks like. Yep. So this is what the data looks like, guys. Okay. So this is your data frame. First of all, let us understand the data. What is the data it looks like, guys? So can someone please tell me what is exactly the data and what does it look like? Yes, it is obviously multidimensional data. So, but what else? So this is basically the sales data. Okay, guys, this is basically the sales data. Okay, so how much amount a company has basically invested and the sales of that specific product. What was the sales of that specific product? Different instances. That is nothing but different instances. Like what are the different instances you have? Okay, so as I was talking about, guys, these are the total whatever the investors, I mean, the companies have invested. This data is coming from an advertising agency, which actually helps the companies to understand like what amount they have to invest on TV advertising or radio advertising or newspaper. Because depending on this amount, this is the sales what has been done. So if someone is basically like working with, I mean, they have invested. Let's say this is $100,000. So $230,000 on TV and $37,000 on radio and $69,200,000 on newspaper. They are getting a sales of 22.1. This can be any product. I'm not sure what exactly the product is, but this is how the sales actually looks like. Okay, this might be the same for the same product. If it was for a different product, then we might not come to a proper conclusion, right? So it depends, right? The total number of products and then the amount which is invested over there. Okay, so anyway, this is how it looks like. So these are the investments and these are the returns. And even I'm not sure whether this is 100,000. This can be thousands also. Okay, I'm not sure. This can be 1,000. This can be 100,000. I'm not sure actually. Let's consider 1,000 to 30,000. That is okay. So let's say this is the amount what they have invested and this is the sales now. So what I have to do is, okay, so first of all, you need to understand that This is multiple linear regression. Here the input now it will be in like two different options, right? So first of all, what we do is, guys, see, it's not always about like, whenever you have the features, yes, guys, whenever you have the features, directly you just don't select all the features here. Okay, so let's just assume that we have to select features and label. So what are the features and label in this data set? What are the features and label in this data set, guys? Can someone please tell me what are the label and size in this data set? Yes, the label will be sales. And how about the features? Yes, except this, everything is basically the features, like sales is the label and TV, radio, newspaper is basically the features, right? Now, guys, before we start working with it, right, we don't actually have to go with all the features at a time. We don't have to do this. Instead of that, what we do is we basically go for one by one. Okay, we basically go for one by one, or one more thing what we can do is we can go with all at once first, and then we can basically decide which one can we drop and which one we do have to proceed further with. Okay, so let us consider the first option where we actually work on all together. Okay, let's work with all three features at the same time, and let's see what exactly happens. So x is equal to nothing but df.ilog, all the rows, and if you're talking about columns, then we are starting from 0 and we go until 0, 1, 2, 3. Yeah, we go until 3 dot values. So this is how your x look like. Control C, Control V. This is Y, and in the Y we are just removing this colon. I believe you guys know the difference. What would happen if I remove the colon? If I remove the column, what would happen? It will just ignore all this and it will just take the third column, which is this one, 0, 1, 2, 3. If you want to cross verify, you can just type X. Yeah, this is what your X looks like. And at the same time, if you need Y, you can also go for Y. Okay. And one more thing, guys, you must have noticed here, I'm not reshaping this. I'm not reshaping X. Why? Because if you check the shape of X here, this is already in 2 dimensions. That is 200,3, right? So yeah, that is what it says. So there is no need to reshape the data. It's already in 2D. So X and Y is done. But we are not going to split the data here. We are not going to do train test split. Why? Because okay, Mayank, I'll do that. Thanks for an update. Yeah, as I was telling you guys, I cannot do a data. I mean, I don't want to. It's not like I cannot, but I don't want to divide the data in trend test split because this is a little bit confusing here. The next concept what we are looking in is actually a little bit confusing. So just to avoid that confusion, I'm not going with trend test split. But if you want to, you can. Okay, but I'm not doing this in this session because I want to explain you some other concept here. Okay, so that is the reason. Okay, guys. So anyway, let me just share this file with your drive so you can actually work with it. Okay, move. Okay, Versio July ML. So I shall proceed further directly with input and output is done. There is no scaling required. So I'll directly go with my regressor. I'll run my regressor directly here. So again from sklearn dot linear model. Import, what do we have to import here? Same linear regression. Okay, you don't have to import anything else. You just have to import linear regression as it is. Okay, and then again the same thing. Lin, create an object basically. Give the parentheses. Yeah, this is the most important step, guys. Some people actually forget about this parenthesis and then they basically get some weird errors. So don't forget to add this parenthesis because you're converting it. You're not importing a class into an object. It's an instance of the class, right? So that's fine. Anyway, lin is done. Then what is the next thing you need to do? Lin dot fit. So what is you need to do here? X and Y. And we don't have train test split here, right? So X and Y. So linear regression is done. Now I want to calculate the error here, right? So I want to calculate the error. So from sklearn dot metrics, basically import mean absolute error. Okay, so mean absolute error, y true and y pred, right? So what is our y true? Y true is y. What is pred y? Yeah, we didn't do pred y. So let us do a pred y here. Lin dot predict basically. And what is the input here? Input, we have to keep it x. There is no other way, right? So anyway, it's okay. Y and then pred y. So we basically have y and then you basically have pred y. Okay. And yeah, this is what the error you get. So that is the error what you have. That is 1.236. This is what the error what we have received. Okay. Suyansh, I have not explained about what you're asking right now. We will explain that later. Okay, don't worry. I'll explain that later. But from where did you get this classification report? I didn't mention classification report here. Classification report is for classification algorithms. We are working with linear regression. Okay, I'll explain that later. Okay. Okay. So this is mean absolute error. So we are getting an error of 1.23. So in the sales, whatever we are getting, right, we can expect an error of 1.23 if we go with all the three features. Okay. Now, if you want to predict individual stuff, what we can do is we can go with lin.predict. And here we can give what is the data? Like let's say some value for your TV, some for your radio, and then something for your newspaper. Okay, 2D array, right? Let's go with 2D array. So if you go with this data, you are getting a sales of 12.65. Okay, so something like that. So what you can do is you have made a model now for an ad agency. You can just show your customer, whoever is coming, clients basically. You can just show them, like, if you invest this much amount in TV, this much in newspaper, this much is in radio, then according to the previous history, we can say that you are going to look a sale around 12.65, something like that. So this is what you can actually do by using our linear regression. We can forecast sales. Depending on the input, whatever the input you have, you just give the input and then we can basically forecast the sales, like how much sales is it going to have. Now, the remaining thing, what I have not explained you here is the equation for multiple linear regression, which I will explain you tomorrow. And the second thing is how to select the important features. Here I have selected all the 3 features, right? But tomorrow I'm going to show you how to select the most important features, and the feature which doesn't make any sense, we can basically remove that feature. So all of this stuff, we'll see it tomorrow. Okay. So thank you guys. Thank you so much. As of now, for today, we are going to do until here. Okay, we are going to wind up our session now. So if you have any issues, any concerns, you can let me know. Otherwise, we'll just wind up. Okay, I'm going to be there for next 2 to 3 minutes. It's okay. We have got some time. So if you have any doubts, you can ask me. Otherwise, we'll just wrap up the session. Okay. If you have any concerns, any issues, any doubts, please let me know. Thank you. Thank you so much. Thank you guys. Thank you. Thank you so much. If you have any issues, you can ask me. Okay. Okay, then thank you guys. Thank you so much. We'll sure, Mohammed Hassan. Thank you. Thank you so much. Bye bye. Take care. Bye bye, everyone. Thank you so much. We'll see you tomorrow then. Okay. Bye bye.